to work through test review part 1 for you so that if you're at home and you don't know why you missed one of your questions on your review, you can work through with me or go through the process. So questions 1 through 3 you want to solve using elimination. So number 1 is set up perfectly. It's already ready to eliminate your y. So you're left with 2x, 10 minus 8x, 10x minus 8x, and then equals negative 16. So x equals negative 8. And then when you plug negative 8 in, so negative 8 times negative 8 minus 8y equals 0. So 64 minus 8y equals 0. So 64 equals 8y divided by 8. Y equals 8. So your solution is negative 8, 8. Okay, number 2 is not set up yet to eliminate. It's got your variables lined up, but you need to multiply one or the other. So if you multiply, let's eliminate y. If I multiply the bottom by 7, I'll get 49x minus 7y equals 42. And so when I combine these two, I get 48x equals 48. So x is 1. So if I plug that back in, negative 1 plus 7y equals 6. Add 1. So 7y equals 7. Y equals 1. So your solution is 1, 1. Okay, number 3. Number 3. Again, you are not ready to eliminate anything yet. You actually need to multiply both equations. So let's go ahead and eliminate y since one is negative and one is positive. So 3 and 5 both go into 15. So I'm going to multiply the top by 5 and the bottom by 3 in order to get those there. So bringing this top one down, 25x minus 15y equals 80, and the bottom one, 12x plus 15y equals negative 6. So you end up with 37x equals 74. So x is 2. If I plug that back in, 5 times 2 minus 3y equals 16, so 10, and subtract 10 from both sides, negative 3y equals 6, y equals negative 2. So your solution is 2, negative 2. Sorry, that one's kind of scrunched. Okay, moving on. For questions 4 through 6, solve each system by using the method of your choice. If you're going to graph, you need to use graph paper and staple it to your test review. It says quiz, but it should say test review if you chose systems graphing. So that first one, I actually would have chosen elimination because I can get x to be negative 5x by multiplying it by negative 5. If you use substitution, you are not wrong. You will get the same answer as me. But negative 5x minus 10y equals negative 30. So negative 7y equals negative 28. So divide by negative 7. Y equals 4. So go back and plug it in. X plus 2 times 4 equals 6. So x plus 8. X is negative 2. So your solution, negative 2, 4. Okay, number 5 is set up perfectly for substitution. You have one equation solved for y, so we're going to plug it in for y here. So 2x plus 2 times 2x minus 9 equals 12. So 2x plus distribute 4x minus 18 equals 12. So 6x minus 18 equals 12. Add 18. 6x equals 30. X equals 5. So then plug in for y. 2 times 5 minus 9. Y equals 10 minus 9. Y is 1. So your solution is 5, 1. Okay, and then number 6, again, set up perfectly for substitution. 4x minus 2 times your new y, 4x minus 3 equals negative 7. Distribute. Make sure you distribute a negative 2. And watch your signs. So then combine like terms. Subtract 6. Divide by negative 4. And you get x equals 13 fourths. That's fun. So we'll plug that back into that first equation. Y equals 4 times 13 fourths minus 3. So that would be y equals 13 minus 3, and you get 10. So your solution is 13 fourths, 10. Okay, for number 7, write the system you do not need to solve. So James Harden has some nickels and some quarters. There are 6 more quarters than nickels. The value of the coins is $2.70. How many of each coin does James have? So you need to talk about quantity and you need to talk about value. All right, so he has some nickels, X, and some quarters, Y. Ah, no, back, sorry. You have 2 different scenarios. One of them is the value. So let's talk about value. You know that a nickel is 5 cents and a quarter is 25 cents, and the total value is $2.70. Okay, and then that second system is that sentence right there. There are 6 more quarters than nickels. So your quarters is equivalent to, or quarters, which we said was y, was x plus 6. So nickels plus 6. So there's your system. If you used Q and N, that's okay as well. All right, so the next one you want to write and solve. So the attendance at the school concert was 53 people. Admission for the adults, X, and children, $4 for children, Y. So there are your variables. The receipts were $317. How many adults and how many children attended the concert? So adults and children, there were 53 people. For each adult, they charged $7. For each child, they charged $4. They made a total of $317. So there's your system. Then when you solve it, I'm going to multiply this by -4. I shouldn't have used that. Times -4. So -4x minus 4y equals 12, 20, -212. And your second equation is the same. So you've got 3x equals 105. So x is 35. Plug x back in. 35 plus y equals 3. So there were 18 kids. Okay, association, causation, or no correlation. The warmer it is outside, so as temperature increases, the fewer layers of clothing one has to wear to be warm. So it's negative, but it's just a correlation. Some people are hot-blooded, so you cannot say it's causation. There definitely is a correlation, so we would call that association. Strength of association between two variables, x and y, is being determined by calculating the correlation coefficient R. Which of the following results would indicate the strongest linear association between the variables? So you want the closest to either 1 or -1. So you have -0.84, 0.87, so this is already not the best. And then 0.87 and -0.92, well, that one's out. So now you just need to compare the last two, which one is closer to 1 or -1, and it would be this option. Okay, flip to the back. Which situation best represents causation? So one thing caused by another. When the number of bus stops increase, the number of car sales decreases. No. When fewer firefighters report to a house fire, damage caused by the fire decreases. No. When ice cream sales increase, incidents of sunburn increase. No. When it rains several inches, the level of the lake increases. Yes. A lake is a closed body of water, so if it rains, it's going to rise. Okay, the table shows the estimated percentages of students on honor roll for 4 years. Draw a scatter plot and trend line on the graph to the right. So in 2009, it's 25%. In 2010, it was 27%, 11, 38, 12, 40. So then to draw a trend line, about there. So if we were going to estimate 2016, you have to use your line, so your answers might differ a little bit from mine. If I use this point right here, so years since 08, that would be 1 year, and at 20, and then used this point here at 2012, so so my slope would be 20 over 3. Okay, and my y-intercept is about, I'll just use point slope. So y minus 20 equals 20 thirds times x minus 1. In 2016, that would mean that x is equal to 8. So replace this with 8. 8 minus 1, 7. 20 thirds times 7.
I got it.
Is 140 thirds plus 20. So that comes out to 66.6 repeating percent. So in that neighborhood, because I'm pretty sure my key on Canvas says 75%. All right. Use the scatter plot, so we're using this scatter plot. What does the correlation coefficient of the data indicate about the strength of the linear association between the student's study time and test grades? So moderately strong positive correlation, those points are pretty close together. What would the prediction for a student's test grade be if he studies for 80 minutes? So you're interpolating here, somewhere around 90 to 95. Because it would be in this realm right here. Based on the data, so remember we eliminated these, which of the following are most likely true? There's a positive linear correlation between study time and test grades. True. There is no association between study time and test grades. Well, if that was true, the previous one would be true, so that has to be false. The association between study time and test grades is an example of causation. False. And the correlation coefficient, which you already said was moderately strong, can't be 0.28. So the only one that's true is number 1.